All right, esters. Esters are basically things that, or what we use them for, like in real life, is for smells, for artificial scents. So we're going to take a look at some well-known artificial scents, and then we're going to take a look at the actual reaction to create an ester. So typically things that have artificial scents like perfume, lotions, gum is another one here, like that wintergreen, wintergreen, uh, a smell of gum or taste of gum, is methyl salicylate, which is a very, very common ester. It gives you that sort of like pepperminty smell. Most of esters have like either like a fruity or some sort of like sweet smell. So you can see here, like, um, if I'm going to mix an alcohol with an acid, so these are acids on this like left margin, and these are alcohols across the top, I'm going to get an ester. So esters that smell like these are mint leaves. So these are all of the hexanoate, heptanoate. Those are all um, uh, acids that will give me like a pepperminty smelling. We've got coconut, we've got like floral smells in here, oranges. So why I wanted to point this out is because there's also things like there's a candle here, there's red wine, there is like glue up here. Um, let's see, is there anything? This is wood. I mean, I guess actually wood's natural. Forget I said that one. Um, I can't tell what that is, but like I said, perfumes, lotions, gums, none those things aren't grown, right? They have to be made, which means you have to add esters to them in order to give them the smells that you want. So right now in the industry, I guess, the industry related to consumer products, there's a big divide between whether artificial scents are bad, whether you should be extracting them naturally or if you should be making them artificially. Um, and it honestly depends on what we're talking about. If you're ingesting them, you might want something that's derived naturally. That means instead of making the using the alcohol and the carboxylic acid to make the ester, like say for an orange, like instead of using the octyl acid or alcohol and the ethanoate acid to make that orange smell, um, instead of using octyl to make the octyl ethanoate ester, which is that orange smell, maybe you just get an orange and you extract the orange through the rind or through the juice or something like that. You extract it naturally rather than getting the octanol and the ethanoic acid it would take um, to make that ester. Uh, a lot of your food products tend to have naturally sourced things. Like you'll buy things and it says like naturally or organic or something like that, which means again that it's not made like in a lab. But a lot of your like lotions and perfumes and colognes and I don't know what else has like an artificial scent, that's not a consumable, any of that kind of stuff, candles, they all tend to use artificially made esters. And sometimes those products are absorbing into your skin and sometimes they're not. And the ones that are not probably don't matter really. The ones that are the ones that people tend to like want to think about, because when you think about like cleaning products like soaps or even like face washes, like things you're going to use on your body, cleaning products, sometimes you might not want something naturally sourced because there's more of a chance of like irritants or allergens versus something that was made in a lab. You know exactly what it is, versus something that you're going to absorb into your skin. Maybe you want something that's more natural because you don't want to put chemicals in your body. So there's a lot of debate right now on this specific topic, and this is really why. It's because there's two ways to get esters. You can make them or you can naturally sort of extract them from where they naturally occur. Um, the type of reaction is called a condensation reaction. When you're making an ester, it is a very delicate process. It's made by mixing an alcohol and a carboxylic acid. When you have too much alcohol, it starts to smell like a cleaner. A lot of cleaners, household cleaners, have alcohol in them. I think we learned that this year with COVID, or if this is next year than last year with COVID. But I think we learned that in our recent history that alcohol can kill bacteria. We've seen that in like the hand sanitizers; they have to be 70% alcohol in order to be functional. So, yeah, alcohol smells like our cleaners because that's what is in cleaners is alcohol. So when you're making an ester, which is supposed to smell good and fruity and sweet and flowery, if it smells like alcohol, it means you had too much of that. If it smells like cleaner, I'm sorry, it means you had too much of the alcohol. Now, if it kind of smells like stomach bile or like throw up, that means you have too much of the acid. Acid is a very rancid smell. So like I said, it's a very hard balance to get an ester. Because it's a very delicate process. It takes just the right amount of alcohol and just the right amount of acid in order for the ester crystals to sort of form and to get those nice scents. We used to do this as a lab, but we don't do it anymore because hexane is the solvent, and it's a chemical that when inhaled, it can do some damage to your lungs. So we don't do it anymore. But this is the reaction where you have, so I have methanol here. It's an example of an alcohol. We have our carbon with our OH, no double bonded oxygen, nothing like that. So we know it's an alcohol. It also ends in OL, so I know it's an alcohol. And then my butanoic acid, I'm going to add those two together. Again, it ends in oic acid, so I know it's my acid. It's got the OH as well, but this time it has the double bonded O, so that's the difference between the alcohol and the acid is that double bonded oxygen. And so to make the ester, we call it a condensation reaction. If you remember, it was condensation reaction because it makes water. When you hear condensation, hopefully you think of producing water, which is what it does. We take the H off of the alcohol and the OH off of the acid, and we make water down here. And then right where we took those off, we attach. So that oxygen here will attach to this carbon here, and that's what you see down here, and that makes our ester. And then we use the names of our alcohol and our acid to get the name of our ester. So on our alcohol, we drop that ending and add YL. That's how we got methyl. And then butanoic, we drop that ic and we put 8. So butanoic becomes butanoate. So that's how we got this name down here for the ester methyl butanoate. So again, it's called a condensation reaction because we're taking out the water and then we're attaching that oxygen and that carbon together to get the ester. You, in your notebook, you will have to do some of these. I did a few examples for you, and then you will need to do the rest.